Welcome to this explainer. Today, we're diving into something absolutely fundamental, how we bridge that massive gap between human thought and machine execution. We're going to unpack the core concepts of programming and problem solving, focusing specifically on building a strong foundation with a C programming language. It's a journey from abstract ideas straight to concrete working software. But, before we even touch a single line of code, we really have to ask ourselves, how do you actually solve a complex problem? When faced with total chaos, what's our natural instinct? It's so tempting to just jump in and start trying things out. But as we'll see, real problem solving requires a much more deliberate strategy. Here's our roadmap for this explainer. 1. The engineering mindset. 2. Mastering problem solving. 3. Programming, the practical solution. 4. Why C still matters. And 5. Your path to mastery. All right, let's kick things off with part 1, the engineering mindset. It's kind of like a giant puzzle happening right inside your head. True engineering thinking isn't just about crunching numbers. It's this incredible combination of creativity, logic, and practical knowledge. Curiosity is the spark, right? But it absolutely has to be paired with analytical and systems thinking to actually work. That's the secret sauce that turns a massive challenge into a real opportunity. So the core thing to remember here is that engineering thinking is not about guessing at all. It heavily favors strict logical reasoning over simple trial and error. You take a massive, intimidating problem and you break it down into tiny, manageable pieces. We call that problem decomposition. And you're not just grabbing the first fix you see. You're constantly evaluating alternatives based on things like cost, safety, and reliability. It's a highly structured, iterative process of continuous improvement. Moving right along to part 2, mastering problem solving. So with that mindset locked in, how do we actually do it? Well, there's a fantastic 8-step process for this, and it works like a continuous loop. You start at the very top by identifying and analyzing the issue. Then you generate and evaluate your alternatives. After that, you implement the solution, test it, improve it, and finally, review the results. It's literally a cycle designed to squeeze out the absolute best possible outcome. If we chunk those 8 steps down into 4 broader phases, it really highlights the engine of this whole process. Step 1, identify and analyze. Step 2, generate and evaluate. Step 3, implement. And step 4, test, improve, and review. You know the old saying, a well-defined problem is already half solved? It's so true. If you can define exactly what information you have and recognize exactly what's missing, you're already way ahead of the game. Okay, part 3, programming, the practical solution. Now we transition from the abstract into the concrete. We really need to contrast these two things, the thinking process versus the practical implementation. Problem solving is the human side. It's our brain's ability to strategize and design a solution using things like algorithms. Programming is the execution. It's where you write the actual instructions to make the computer carry out your brilliant strategy. Put simply, better problem solving leads to better programs, for sure. And here is how that magic actually happens. You start with your algorithm, your step-by-step human logic. Then you write it out in a high-level language like C. But here's the catch. The computer's CPU has no idea what C is. It only speaks machine code, just ones and zeros. So a compiler steps in. It acts like a translator, converting your C program into machine language, and then, boom, the CPU executes it. It's a pretty amazing journey when you think about it.
Which brings us to part 4. Why C still matters.
Now, you might be wondering, with all the flashy new AI-era programming languages out there, why on earth do we start with C? Well, check out this timeline. It was created by Dennis M. Ritchie at Bell Labs way back in 1972. Yep, older than the internet. It was originally built to implement the Unix operating system. But it didn't just stop there. It became the bedrock of modern software. It's literally the foundational DNA for huge modern languages like C++, Java, C#, and Go. Crazy, right? There's this quote that I absolutely love, and it just hits the nail on the head. C is not merely a programming language. It is a foundation for engineering thinking. Learning C actually transforms you. It forces you to become a disciplined computational thinker, someone who understands what the machine is doing under the hood, rather than just someone who memorizes syntax. So what's the actual payoff for you? Learning C first gives you a massive advantage. It sharpens your computational thinking and really strengthens your algorithmic design skills. Plus, because C gives you direct control over the computer's memory, it essentially forces you to understand underlying memory organization and computer architecture. By the time you're done, you are more than ready to tackle advanced data structures. Finally, let's look at Part 5, your path to mastery. So how do we build this mastery? Well, it happens step by step. On the foundational side, you'll tackle algorithms and flowcharts, basic input and output programs, decision-making, and loops. Once you've got those locked in, you graduate to the heavy hitters: functions and recursion, dynamic memory allocation, pointers, structures, and complex file handling. Even matrix operations and sorting. It's a completely comprehensive toolkit. Ultimately, the whole shebang, the engineering mindset, the problem-solving loop, and the C language itself, serves one core purpose. It's all about giving you the power to take an innovative idea floating around in your head and transform it into a real, working software solution that solves a practical problem. So I'll leave you with this one question to chew on. Now that you're armed with this disciplined engineering mindset and a true understanding of computational thinking, what real-world problem are you going to solve first? What will you build? Thanks so much for hanging out with me for this explainer, and I seriously can't wait to see what you create.